turn the music down a little bit. There. Good afternoon. Well, this is a new time. It's because I want to try and get a lot done today, I guess. So, how's the audio and how's everyone doing? Live. Huggy D1 made it. Nice. So let's see who showed up first. Oh, it was Draadstaal, and then Johnny Bergdahl was the first mod. That's true. Will he be early or, as always, or he's going to be on time today? I was a little bit early, like 2 minutes. Let's go off with a bang or smoke. Yeah, well, we'll see what happens. They are prototypes, so... Christmas lights, Zwolle. Hey there. Yeah, John, we're having a really early live stream today, and then probably also a later one, because I have a few boards I want to build and test. And I was like, well, I'm in the garage anyway and doing this. Why not take you guys along? My camera seems a bit high, doesn't it? Is that better? No, not really. That doesn't look right either. Hold on. What's going on? Something like that? That's better. Oh, all the way around. There. That's better. There we go. So, whoa, there's already 46 people here. I didn't expect too many people because I just announced it like half an hour ago. But what we're doing today is I have some prototype boards of the Sender 4, the midpoint 1 and the midpoint 2. We did about we did another prototype run of those I think 2 months ago, but these are the new and improved versions. So we'll be building those and then be testing those, and probably today's mostly going to be building and then tomorrow testing, or maybe we'll just go everything in one go, or I don't know. There's probably going to be a break in there somewhere where I go eat. But yeah, is my camera focusing? I think so. Yeah. So yeah, well, we're just gonna see. One of you didn't hit the like button. You know who you are. I changed the setting on my camera, and now I'm not sure it's actually focusing on me. Well, we'll see. Let's get started, because well, there's a lot of stuff to do, and let's see. Can we zoom out? There. Oh, look at that view. We have this PCBWay box here. Let's try and get this out of the view. Oh, and we have a can of Coke, of course. But this is a special one, and I don't believe this one is over the date. Let's see here. 09/01/24. So I need to drink this one. Yeah, but this is Pepsi Max Coke Mango. Mango? I don't know, man. We'll have a look at that, or we'll have a sip of that. But I have a nice PCBWay box here, and they sent me a nice little Christmas card, and Merry Christmas and Happy New Year. Thanks for supporting PCBWay. Well, you know, we have three stencils here, so we're gonna need those for the paste application, and then we have some prototypes boards. So this is the midpoint 1. Let's see here. I guess you'll want to see that more up close there. So this is the midpoint 1 board, but we're going to do that as the second board we're going to be building today. In theory, if I feel up to it, we're going to be building 3 boards today and then 2 of each, but we'll see. But we're not going to start with the receiver one. We are going to start with the, this is the receiver midpoint 2. But we're going to start with the where are we? The data diff sender. So yeah, or the sender 4 actually, because the diff solo, as I've dubbed them, are actually now in production. So I'm hoping to be able to launch those early next year. But the solo are really meant for one-to-one, very simple, little features, connections with RS485. And so you can get your LED data signal to where it needs to go, even if that's a few hundred meters away. So the sender 4 are these boards. Let's see here. Yeah, sender 4. Oh, this still says Data-Diff. I think I've decided to rename these to Diff. So I'll need to make a note of that to change that. And well, those are these boards. So we're going to build 2 of these, because building 2 takes like 1.5 times the time of building 1. But then we have 2 to play with. So that's good. Put this in here. There. So now we need to find the right stencil. And well, I can't really tell from these names, so we're just going to have to cut those open. Put a hole in the bottom and empty it that way? What? Oh, the can, you mean? No. I'm just gonna drink it. I don't care. Did we get the right stencil immediately? No, we did not. Oh, okay. So we need this one later. I have a 3D printer. I had an Ender 3 for years, and it upgraded in some ways and blah blah blah. And I recently got a Bamboo Labs X1 Carbon. Do we need this one? No. Of course it's the last one. And currently it only has the built-in LEDs. The Ender 3 had some modified LEDs. It had some Oxmer analog strip on there. Do we need this one? Yes, we do. Good. Build a Voron. No, I don't 3D print that much. And even the X1 Carbon is a little bit overkill, but I use it for certain prototyping, which it's helping out a lot in, so it's a good investment in that sense. Okay, let me get my board out. Oh, my paste application board. It's a bit overkill, maybe. Who knows? Yeah, the X1 Carbon so far has been great, and the things I've printed with it came out excellent. So. Well, I needed it as a work tool, so that's why I got it. Let's see here. We're going to try and keep some pace here, because I only have like 1.5, 2 hours right now. And then I'll take a break to have some dinner, and then we're probably going to be continuing later again tonight. So it's going to be lots of streaming, If I do it like this, then it goes like this. Let's see here. Yes. Okay, good. So let's put that over there. Oh, this is still stuck down. Okay. So clamp that in there, and then let's stick it all down. And last one, this little piece over here, I guess. As long as it's in there pretty secure, that's fine. Oh, extruder failures. Okay. Well, the parts are easy to get and to replace, so, I mean, shouldn't be too big of an issue. Let's try and align that. Try and show you a bit better. Nope, other way. There. Well, it's going to be a bit hard to see. Hold on. I need to get my phone out. There. But I'm going to try and align that correctly. There. Yep, need some extra tape. It's a bit dark, isn't it? Let me... There. Oh. Is that better? Dick quad fuses saved me when I measured voltage with red probe plugged into current plug. Oh! Yeah, that's not gonna fly. Yeah. So let's see. Okay. That seems stuck down. And now we're gonna do something. I got some new paste. Let's see, there's no address on there, is there? No. I got some new paste and Chip Quick. The 138C stuff, because the jar I had was already 1.5 years old, I think. So I thought, like, okay, let's get a new jar. Can't hurt. Now would be a good time to insert an ad. Do you know when it's a good time to insert an ad? Never. Okay, let's get my tools. Now, I tried to keep all the ads of YouTube away, but they're making it harder and harder to not have ads. But, yeah, they ship it with some electrical tape on it. I guess they really don't want it to leak. Go for the ad. I have premium. I have premium too, but, you know. Everybody's welcome here, premium or not. Was it Dutch on there? Because it's from Mouser, so they ship it internationally, I believe. Okay, so when is there a date on this? Yeah, let's see. This is manufactured 2305. Oh, okay. And I just got it this month, huh? Oh well. Premium Max. What does that do? Oh, there's even extra plastics in there. Oh, better prepare a little tissue for that. Hold on. Okay, that is now encased in tissue. Good. Oh, the smell of fresh solder paste. Oh, look at that. Okay, let's give it a little mix here. A bit dry. Come on, I'm gonna zoom out a little bit. There. We might add some more flux later, but it's starting to mix up, so that's good. Okay, so let's put a little bit on the stencil. Like that should be fine. Well, let's do a little bit more on that side here. Can't hurt to have too much, because we can just put it back in the jar. That's why I use a jar instead of a syringe. Okay. So let's see if we can do this. Oh no, the stencil isn't wide enough. Well, we can make it work. So let's make this into a nice bead. So it's kind of you know, like that. And then yeah, that looks pretty good. Let's have a look. How's the music volume? Not too loud? Yeah. That looks pretty decent. It's not too thick, but it should work fine. Okay, let's do the second one. Oh, nope. Not tight enough. Let's see, how am I going to do that? Cool. Thanks, Christian. That's exactly how I want it. Now let's see if I can do it again. Yep. That again looks pretty good. Not too thick. Yep, that's good. Okay, now let's clean this up. Now the stuff that's left on the stencil, I don't care about too much. It's not that much anyway. So let's get a tissue and clean that off. Fuses are for wimps until they aren't. Exactly, Johnny. Oh. Yeah, secretly I'm just streaming earlier because Johnny always goes to the bars. So now he doesn't have that excuse. So he'll have to stick around. But as a compromise, or as a thank you for that, I do now have those 0402 pink LEDs. We could use one as a status LED on one of the boards. So that would immediately make the product like 10,000 times better. Okay. Yep, that's clean enough to store. Okay, this can go away. Is there a speck on the lens? Don't think so. What do you see? Let's see. Let's do something white. No. don't think there's anything on the lens. Is there anything on the lens? Nope. Oh, the heart. Oh, okay. Yeah, the heart's still there. I don't mind the heart, actually. Okay, so let's take these boards and let's see how we're going to orient them. I think like this. Let's do a bit of zoomy. I think this is the maximum zoom I can do right now. But that should be pretty okay. So now the search for components begins, because it's all sorted into my boxes. Let's get a tweezer. Okay. There. Let's take off my coat. Hold up. I did not set my phone to silent. There. Okay. Right, so let's get the iBomb file. This should be charged enough now. Yeah, Johnny. Although I think Chris Maher makes nice videos, he seems to skip a few steps, in my opinion, in regards to power and fusing and power distribution and things like that. So I think I'll just remain on YouTube for now. Let's see. Sender 4. Okay. Uh-oh. Some USB device just connected. I have no clue what. Let's see. Can I show you guys? Browser. Yeah. Wait. One moment, please. Okay, and then there. Okay, but that's really big. We're looking at it like that. So then let's do this. And then I can zoom in. But now we need to make this smaller. I guess this could work, right? You guys can see Oh, he powered the full strip off of the VCC pin of his dev board, limited to 1 amp. Oh god. Yeah. Yeah, what am I gonna say, Johnny? I mean, what are we gonna do? I guess what we're gonna do is just teach people how to do it right. So, I mean, that's the best way to fight against that. Nice, the cure. Well, you have some fun soldering projects planned then. Let's see here. I can't actually see my screen anymore if I do this, but we'll do it anyway. Yeah, so let's start with that capacitor. A 0603 0.1. Capacitor 0603. 30-minute notice? Oh, yeah. Sorry, Philip. I'm sorry. No, this is 0805. What? Why is this? Oh, this is wrong. This is an 0805. That shouldn't be in the 0603 box. 50 volts. Yes, I need this one. I hate that I can't see the screen at the same time. Let's see. Can I move this over here? But then that'll wreck the whole window, doesn't it? One moment here, please. We're experiencing technical issues. Oh. It'll have to be like that. Hopefully you guys can see it. Okay, so we need 2 of these because it says 1, so we need 2. So a diff board, well, basically like Johnny says, it's used to get the signal over longer distances. So where normal LED data really craps out at like maybe 10 meter or something like that, if you're using one of my boards, with this solution, you could go 100 meters or even 500 meters, and it should still be fine. There. What's this guy? Oh, okay. Do I have more 0603? I do. I have a 10 here. So let's do that. Then 16 volts, 25 volts, that's fine. We need 2. Yeah, 500 meter. Well, we did some tests with several connections in between actually, and we got up to like 400 something meter before I ran out of cable. No, or maybe 500 even. I don't even remember what we got, but it was so long that I didn't have enough UTP cable to to make it not work. Okay. There. Okay, next. That should be all 0603 capacitors, so let's do some 0402s. Yeah, it's a really long way, but it's also, I mean, it's not really meant for like 500 meters. It just happens to work. But it's meant for like if you need to go beyond 10 meters, there's a good chance your LED data isn't going to work. And well, this solution is a lot more robust in that sense. So then you can use this. 22, 116 volts. Yeah. So we need 5, so we're going to use 10. Ooh, ooh, ooh. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's leave this here. Where did they all go? The one needs to go over here. There, let's see, is that okay? We'll have to do some corrections with the microscope later. One goes over here. And then the rest goes over here. Okay. Good. Yep. So now we need a 1 UF. Let's see, do we have some of those? 50 volts, they need 50 volts, 25 volts, 10 volts. 10 volts a bit low. Sure, let's do 25 volts. And we need 4, so we're going to get 8. Why 0402? Why make them bigger if they don't need to be bigger? Especially since this is going to be a pre-assembled production board. So, I mean, the machines really don't have a problem with 0402. And there's also some electrical advantages, actually. You'd have to look at the ESR plots and charts, stuff like that, to find those. So yeah, you should select the package size and value you need, but the package size is actually part of the value. Oh, I messed this one up. There. So there's actually a difference between an 0402 and an 0603 and an 0805. It's not that much, but at some point it does start to count. Let's see, that should be those. Yeah, they're hard to see, but I'll check them later with my microscope. Smaller is cheaper, not always, but for some stuff, yeah, that's true. Let's see, were those the 0402s? I think so. So now we're going to 1206. Oh wait, I need to put this back. $12.06 is easy. If I can find where they are, I think they're over here. Oh. No. This is a differential converter board. Let's see, 1206 2.2. Oh, immediately got the right one. So this takes in a LED data signal and then transforms it into a different type of signal, which can easily run for hundreds of meters. .2, 100, Oh, there! Hi there, Kimi Nico-chan. Great, you're enjoying the Dig Octa. Yeah, shipping is one of the things that's on the top of my priority list. We recently did a change. It's not official yet, or I haven't officially announced it yet, but AllNet now ships all shipments to Europe with iOSS. So all the taxes to Europe are now prepaid, so you don't get a tax hit anymore when you receive your package. But I'm testing that myself first to verify that it's actually working. Now, I have actually received my package yesterday, just like these boards, and so far as I can tell, it's working perfectly. But I will announce that early in the next year. You did hear iOSS there, Jocko. Okay, no more 1206 is needed. So we're going to resistors now. And 0603. 0603 resistors. Networks. Resistor, let's see, 120. Oh, okay, I'll get them all. I think we need low. Awesome, the cure, and thanks there, Vance. Let's see, 120R. 100 unnamed bag 120, and we need 4, so we get 8. So yeah, I guess that's the secret from this stream, that iOSS has been live on AllNet for the last 1.5 to 2 weeks. I just haven't told anyone yet. Let's see. Oh, these go over there. Yeah. Because, as with most things, I wanted to verify that myself first. Are you working on any new controllers there, Leon? Because I believe you also make some controllers there, Leon Vos. No. There's some hairs on my tweezer. There. EMS bus. Oh, what does that do? Okay, that looks pretty good. The rest should be 0402. Yeah. Multiple streams, multiple secrets. I don't know, Philip. I'm bad at keeping secrets, so I don't even know if there's that many secrets that are still out there. So this can go in the back. Let's see here. We need 16K, 20K. Oh, okay, so we need under 10K. No, I don't need this box. What? Interesting. Resistor 0402 low, under 10K. That would suggest I also have a box that says above 10K, right? Let's see what's in here. 5.1K. Yeah, no. So I need another box. Where is it? Okay, let's try it again. Resistor, no, 402, capacitor, PTCs. I need more cable. There is no more cable. Okay. Capacitors, PCB buttons, huh. Interesting. Let's get this stuff out of the way. MOSFET, Zener, Diodes. How is this possible? Is it down here somewhere? Did I hide it? What? Am I just not seeing it? Is it right in front of my face? No. Central heating. Oh, okay. Cool. Right. Let's not pay attention too much to chat because I need to find this box. Oh, where could it be? Can't be back there. I am so confused. Did I put it? Hold on. can a box like that disappear? I never get that. That's not possible. Okay. So now what? Cool. That sounds fun now, Leon. Where could I have put this box? I really don't understand. It should just be here. Let me think. Is it in there? No. What? Where did it go? I am an idiot. Okay, I need to correct this. I did this myself. Because I guess I didn't have a lot of above 10K resistors. So I put it in a small little box like this. But if I'm scanning my closet, I just don't see that. So that doesn't work. Okay. 16K, 12K, 15K, 15.8K, 16.9. Oh, okay. Okay, 20 we need. The best part is I probably need to get it from my resistor book because I don't have that value. 0402 100K, that shouldn't be in here. There. Let me look up if this is the one, which it likely is. Yep, 16K. Let me make a label for that. One moment, please. There. So now we have a baggie which has 0402 16K. Exactly what we need. It's like magic. Yeah, the currently the Diff Solo, so that is these guys, but slightly newer versions or different revisions. These are the Solo Diff boards, so this takes in a LED data signal and power, sends it out over RJ45, only the data signal, and then it receives it, and then it outputs again through a fuse and power and stuff like that as a LED data signal again. And then in between these boards you can have like 100 or 200 or 500 meters of cable, and you can transport your LED data signal that way. Those are in production, and they are currently in assembly. And my dig to analog board here, those are also in production, and they are also currently already at assembly. So I'm expecting those in the first, maybe the second week of January. Oh, detached garage, yeah. Welcome to the rabbit hole. Okay, I need 2 of these. Come on. Not sure if these are these, but we'll see. There. 2. And where did they go? They go over there. Oh no, it said ploink, and then it was gone. But I had some spares here, so I'll use that. There. We need some 20Ks. All your money will be turned into lights. So the stock for the analog boards in US is kind of going to be the same as the stock in China, plus or minus 1 or 2 weeks. Still, oh, messed it up. Hold on. Yep, that's 2. Sure, no problem there, RJ Riemann Snyder. Let's see. There. That, oh no, it didn't sort right. Why is there an inductor suddenly here? Okay, 5.1K, 51. 51 should be in here then. 51, yep. We need 5. Okay, so we need 10. Wait. 51, we only need 1, so we need 2. Come on. No. Sure, detached garage. The ESP32 can handle about, well, let's say 2,000 to 2,500 max, but 2,000 for sure. You just have to do it on different channels. Okay, 51K is done. Let's move those away. This is actually a 4-channel one there, Fun Fam. So these should be done. And now I need the 0402 low for 5.1Ks. Nice! There, John O'Brien. So here we need 10. Clean, yes. Yes. Okay. Why do they always fall out of the bag upside down? What do you do today, flip resistors? I hate it when they get stuck to the tweezer. There. That should be good. J1. No, they should all be pretty much length matched. Which one did you mean, Philip? Can I zoom in more? No, can't. Because these are pretty much length matched. They should all be pretty much length matched. Maybe not to the 0.1 millimeter or whatever, but still. So this one, for instance, this one over here, which does that and then that, that's just, you know, to length match them. The track right next to the text J1. Yeah, maybe I could have. The outer track might be slightly longer than the inner track now, but I should have. I have checked all the tracks in the PCB software, and it came out pretty much even up to maybe 0.1 millimeter or something like that. And that's for these type of signal. That's fine. So okay, that should be most of the small-ish components except for the LED. So let's see what we're gonna do. Oh, too much cable. Let's do some diodes. Oh, let's do some LEDs. There. Let me try and find those pink LEDs for Johnny. SMD LED. Oh, look at that. Yeah, I did put time into optimizing all the differential pairs. Yeah. On this board, and especially on the midpoint boards, because there was a slight challenge because of all the changes I had to make, and the switches and things like that. There. Let's see if I can determine which side is ground. I never know. Is the side with the green stripe ground or not? I think so. But I never know. there, well, it says orange in my bomb, but they are now pink. Let's see here. Okay. Let's do the Zener real quick. Why don't I have the part number for that? That's stupid. C29. Yeah. Okay. Yeah, if you have like 2500 LEDs, might be time to move to 2 boards or something like that. So we need to find the stripe. Okay, we did. And I never remember. The stripe should be in the... Wait, did I now put my LED in the wrong spot? I did, didn't I? Hold on. What did I do? I put the LED in the wrong spot. There. Okay, that is the Zener diodes done. So let's do the normal diodes. $60 volts. That one's gone. Oh, thanks, Guido. Thank you for a fantastic year of streams and informational and entertaining videos. That's very much appreciated there. Thank you. So, diodes. Let me verify something real quick. Yes, good. Okay. Okay. Diodes done. Diodes done. Hold on, I need to open a document real quick. So before I mentioned I needed to change one thing. Oh yeah. No. The sender 4 still says data. Okay. Let's see here. Let's add the boost converter. That should be over here on my desk, actually, on which I have no space left. LGS 6302s. 6302. Okay. Done. Let's get the PTCs. Yep. 1812 and then 300 milliamp. Let's see if I can find those. Yep. In red, Johnny, what happened? Okay. Those go over there. Almost ready to reflow. Almost. Let's do... Yeah, we need to do the differential transceivers and then the inductors, and then we can reflow. So inductors SMD, let's get that one out for now. And I think we need this box. Oh, I actually hope I have enough transceivers left. Let's hope so. Oh, I should. Okay, good. Yeah, easy. 1, 2, 3, 4. 1, 2, 3, 4. Let's make a note real quick. Order more transceiver RS485 transceivers. Yep. Let me check if I got the right ones. I think so. Yeah. Now how do they go on? That's a good question, huh? Where's pin 1? I don't. Oh, I haven't enabled pin 1 in the display. Highlight first pin. There. Good. I'm actually thinking I might have the LEDs reversed. Let me think. No, this should be good. This should be good. Okay. What is the tiny red? Oh, it's this guy. You can press the heart, and then it shows you little hearts. There. Okay, transceivers done. So now we need some inductors, and then all the SMD parts are done. Let's see here. Inductors. 33 microhenries. Yes. Let me check if this is the right one. Yep. No, what? Why are these still in the baggie? These have not been used before, but they are what I specified. Interesting. Did I use the other ones? I did. Okay, well, let's use what I specified this time then. Okay. This can't be right, can it? Yeah, it can. Okay. Those have 14 zones a meter, their detached garage. Right, so let's put it under the microscope, but I need to set that up real quick without messing anything up. So give me a moment here. Oh. What the? How did this happen? Ah. Okay. There. Le microscope. And it needs le HDMI cable. Don't remember where it plugs in. Okay. Let's see if we can do a microscope view. Oh, look at that. I guess we can remove the bomb now. There. Yep. Okay, let's move this over here. Oh. There. Now where did I put my tweezers? Over here. Okay. Yeah, that's fine. So let's do the top board first and adjust everything slightly so that it's better aligned for when we reflow it. Yeah, that's better. Okay. Doesn't have to be perfect, but it does need to be touching both of the pads. Okay, that should be good enough. Let's go to the second board. Okay, that should be good. Yep, let's give that a try. So we need our reflow plate. Let's move this out of the way slightly. There. This goes here, I guess. I don't know. Desk is kind of full. Oh. I need a AC plug, but I don't know where my desk plug went. So we're going to be getting a new one. We're going to be using the still modified 10 centimeter by 10 centimeter hot plate here. Okay, let's turn it on. Yep, let's power it up. going to 155 degrees. So while that is happening, oh god, can I make this work? I think so. There. While that is happening, we put the boards on there. Like the music said, well, here goes nothing. We're currently drawing 321 watts from the socket. That's the power of the modified hot plate. Baking with Quindor, yes. We're currently at 61 degrees. No, there's butter in the flux. Or the flux is the butter, I guess. And then we only have a few through holes left to solder, and then we're done. For this part. Because then I'll take a little break and order some food and eat my food and stuff like that. And then we'll continue at our regular time to solder the midpoint 1 and midpoint 2 boards. And then maybe, if I feel up to it, we'll test them. But that might come tomorrow. This was actually a new tub there, Christian. Oh, it's smoking. We're at 116. Smoky, smoky. 139, okay. So let's keep an eye out for what's happening. Okay, it ticked off, so let's see here. Let's check the bottom board. Some could use a little nudge. There. Okay, bottom board looks good. Sorry if I'm blocking the view. Okay, that all looks good to me. Oh, your own experiments. Okay, yeah, that looks good to me. So let's turn the heat plate off. And let's slide them onto my pad here. there. Now I need to get this out of the way. This over here. Okay, so now let's give it a good check. Let's start with the top board. Okay, so those all look fine. Okay, the top board looks good to me. So let's go to the bottom board. I actually have to move the board now. Some stuff's slightly crooked, but not in a way that would harm anything. Yep, all good to me. Did anyone see any mistakes? Like watching the grass grow. Did anyone spot any issues? Don't think there should be, but you never know. Boring when it all goes to plan. Well, we haven't turned it on yet, Philip. You never know. Okay, let's turn that off. Professional industry microscope. Yes, I feel very, very acknowledged now. Let's see. Let's turn this off. There. We don't need this right now. Oh God. I need a bigger desk. Or something. I don't know. Okay, it's out of the way. Let's leave it there. Right, okay. This one zooms less. Maybe it's because it's further up. I don't know. So we need to add some screw terminals here, and we need to add an RJ45 socket there. Oh, bang. Where are my tools? How many? We will, Johnny, we will, but we first have to add some screw terminals there. Okay, and we need some RJ45. And this footprint, let's see if they cool down enough. Yeah, okay. This footprint should be so tight that it basically just snaps in there. Look at that. Isn't that beautiful? Ha ha ha. Nice. Okay. These should snap in here. I like when it fits this well together. Yeah, good. We passed 100 viewers. Oh, nice. What? What are you spamming there, Johnny? Let me click on that. I thought so. Sure, Philip. Okay, let's put these together. So that makes 6. So we can have 6 like so. Did I do this right? No, I did not. So the text is all lined up correctly, right? So you can easily see the text there. But there's a slight overlap with the board edge. I guess I could correct that, but I'm not sure it's worth it. We'll see. Okay, I can just put these down here like so. And let's grab a soldering iron. Ooh. I am going to hit my microphone at one point. Sorry if I do. Well, maybe I can put it over here. There. Okay, we need some power. No, wrong one. Yep. And then we need some wire. Hand soldering like a peasant. Yes, sorry about that. So let's do this one first. Let's wait until it's up to temperature. I should get my suction device. Hold on. Before I die of fumes, we need some there. Okay. Right, so let's see if I need to correct the pitch of these. I'll do it a little bit. Sorry if there's too much noise. Let's see. Okay. Yeah, they're on pretty straight. That's fine. Okay. I'm using 0.6 millimeter wire, so that's why it might look like more, but let's see the result. Well, maybe a little bit too much on these, but you know. Those look good. Yeah, those look fine. We're currently at 380. Am I? Hold on. Yeah, 380. Okay, let's do the little buggers over there. Okay. Let's see how that looks. No? It's fine. And that looks fine too. Good. So now we have some soldered boards. Let me remove this from my desk because it's too big. Heat plate still be heating. Yeah, we're almost ready for magic smoke. So these boards accept 5 volt to 55 volt. So I can basically use any of my power supplies on my desk here. Because the only thing we're going to do is power them up and see if we have everything soldered correctly. We're not going to function test them right now. So I guess I'll use my 12 volt supply for that. And it has a nice little labels here. Oh, VCC and ground. Let me get a screwdriver. Function testing we'll do later. So these are all rising clamp. Yeah, I can't really show you that. But those are rising clamps, so we have to open them first. I really wonder if I have the LED correctly. No, I should use my bench power supply. Okay, we're gonna jank the bench power supply, because then I can set the current and not blow it up and still have a chance to fix it. Sorry, but I only have forks on there, so we're just gonna jank that in there. Yeah, see, that'll work fine. That's how they're meant to be used. No, wrong hole, wrong hole. That would have been almost magic smoke. Okay. Yeah. Thanks, Secure. Thanks. I caught it in time. Now Philip is sad. That's why I built 2 though. No, but it's like 10 amps. So, I mean, if I'm doing the initial test... Oh, let's do that clamp on the other side. Exactly there, Richard. Okay, so I know you're not supposed to do it this way, but in theory this is on pretty sturdy, so that's not going anywhere. And yeah, we got red on VCC, ground. Now I need to find the cable this is connected to. Oh my god. Okay, hold on. Hear me good. Okay, let's turn that on. There is actually a fuse on there. This... Oh, where's my tweezers? This part over here. This part over here is a fuse. It's an auto reset fuse. Right, so let's set it to 5 volts and 3 amps. Okay, where's my safety glasses? Where are my? Uh-oh. Might have not have safety glasses over here. This is bad. This is bad. Huh. I actually do not know where they are. Okay. Well, we're going to use the hand shield method. So let's do on, and I'll watch on the camera so I can protect myself. There. Oh. Okay, it immediately drew 300 milliamps. Might still not be incorrect, so let's set it to 0.5, 500 milliamps. Okay, it's drawing 200 milliamps, and I think what's happening is that hold on, let me turn on my multimeter. I think. No, other one. Yep. I think I connected the LED backwards, so we're going to do some multimetering. Cannot open device. It's dead, it says. What? Connect. Oh, it might actually be that. Hold on. I probably kinked the... oh god. I kinked the network cable again. Oh, we can get the IR camera out too. But let me see if I can get my multimeter working. Connect. Damn it. Let's see if it got a different IP. did get a different IP. One moment. There, alive. Ah, look at that. Okay. So what am I going to measure? I'm going to measure ground and output here. Okay. So let's give it power. Okay. Ground and output here. .9 volts does not seem correct. Okay, maybe it needs more voltage. Let's give it 7 volts. It's still current limited. I don't understand. Okay, hold on. 7 volts and 1 amp. Let's see what's happening. It's drawing 1.6 something watts. Well, that's not right. Yeah, it's getting 7 volts in. Let's see here. Okay, and over here. That should still be okay. Well, let's first fix the LED. Well, no. Let's get the thermal camera phone. Where's the thermal camera phone? That's a good question, actually. Can you guys tell I prepared really well? Where did I put that? Yeah, I'm trying to get my thermal camera up, but I'm not sure where I left it. Oh, here. Stupid. Uh-oh. It's at 13%. Should still be enough for now. Okay, let's see here. So currently the board is off, but it is 30 degrees. That's interesting. Oh wait, let's fix this. Okay, let's turn it on. It's the PTC that gets hot, and then the ooh. Okay, the DC-DC converter is at 100 degrees. Oh, you guys couldn't see. Sorry. Let's see if there's some residual heat here. So currently it's off, right? So let me turn it on. It instantly becomes 100 degrees. So I turned it off again. Okay. Well, one thing that needs fixing is that the LED is reversed. Now, I can't imagine that creating this problem, but let's fix it anyway, because if I go into a diode mode, okay, and I probe this LED. Oh wait, well, we have some pink light now, but this is correct. Okay. Yeah, so the LED is on correctly. Okay, so it's not the LED causing the issue. It might fix itself. I don't know about that. Yeah, we can try the other board. But I don't understand what could be the issue. Let me verify if I indeed have all the diodes correctly. I think so. Yeah, that's a good suggestion. Let's try the other board. Yeah, I don't think this one can be rotated because it's a 3-2 package, so... Hot air gun everything. Well, it's... Sure, once we find out what the problem is. Well, the reason it didn't turn into a smoke machine is because the PTC is on there. And that limits the current to 300 milliamps. I cease rotated the differentials. These seem all good. Well, I can check, but in theory, pin 1 is this pin over here, and all the little circle thingies. Hold on. No. Come on. What? What are you doing? Are you high? There. All the little circle thingies are in the right spot. So I don't think so. Okay, this isn't touching. That's good. Let's give this a try. I guess we should get the thermal camera again. Okay, so the other board is still hot. So let's see here. Let's turn on power. Oh, no, instantly the same thing happens. Huh. Okay, that is interesting. But why? Let me get one of the previous prototypes. Hold on. getting cold in the garage. Okay, let's get one of the previous prototypes. Let's see. Okay, so this is the previous version. Shouldn't be that much different, really. Yeah, it looks exactly the same. What's going on? Let's see if the diodes are different. No. Oh. I might have made a boo-boo. Fire blanket. I think I might have rotated this inductor wrongly. Because here the inductor is rotated, and over here it isn't. And so let's get the PCBs out. Yep, that's it. So this inductor is correct, like so. And that's the same over here. But that one over here should be rotated, and it isn't. Okay. The other one. Yeah, this one over here, right? Oh. Yeah. Well, we all missed that. So let's see if it blew up the DC-DC converter chip. What, the bottom left one? No, the bottom. This one is upside down. That's okay, but the orientation is still the same. So that's okay. That's fine. But we need to fix this one. So let's put this on the charger real quick. Okay, and let's blast it with hot air. Let's see, we need about 220 should be fine. Don't need a lot of airspeed. There. Yeah, and then you test them both and you make the same mistake on both. And then I'm going to try and get this in the shot, but I'm not sure my hot air station is going to reach because I've run out of disk space. Let's see here. It can. Well, you can't see anything anyway, sorry. Well, that's going to be a problem. Okay, I'm going to have to do this off camera, sorry. Okay, that's one. Hey there, Jamie. Welcome. Okay, that should do it. So now we have two rotated inductors. So that's the top board. And that's the bottom board. Ow. We can actually distinguish them because these have pink LEDs. Now let's cool them down the manual way. Well, no, they're still on fire. I need to cool them down. It is currently 1839. Stream gone. What? Am I still here? Oh, Digital Addressable is here. Okay, so now these should be cool enough, I hope. I don't know. There's no science here. So let's screw this back in. Okay, hold on just a second. What the? Okay. Ground is black, good. Red is VCC, also good. Let's get the thermal camera ready again. Yeah, board's still a little bit hot. Oh, can't see. Okay, board's still a little bit hot, but let's see what happens. Okay, that looks a lot better. Now the RS485 chips, they glowed up, I guess you could say, or they heated up. That's good. No exploding buck converters, or boost converters in this case. Yeah, and these red dots you see over here, those are the resistors, the termination resistors. And they're about 50 degrees, that's right. Cool, okay. So the pink LED is now on. It's a bit bright, but that's because I normally use orange. And of course for a different color LED you need... Oh, it's going in and out sometimes? . Oh, that was probably when I plugged in my phone charger, because it's on the same charging circuit as that one. We'll see that in a minute. But yeah, this is working. That's good. Let's try the other one. I was only drawing about 100 milliamps, I believe. Yeah, it's not the best pink. But then again, pink LEDs are very hard. Do you have a link to like the best pink LED in existence, Johnny? Okay, that should be fine. Let's turn it on. Ah, pink LED. Noise. So let's do a quick measurement, but I believe that is now going to be fine. Oh wait, we're in diode mode. Oops. 4.99 or 98. Okay, that's fine. Okay, let's set it to 5 volt. At 5 volt, it's drawing 0.17 amps or 0.84 watts. That's fine. Yeah, we're still at 4.989-ish. Let's set it to 12 volt. Yeah, still at 499. Okay, let's set it to 24 volt. .0041. Yeah, it's normal that it drifts a little bit with a higher input voltage. Okay, let's set it to 48 volts. I don't know. There. .07. Yeah. Okay, that's good. Of course, the LED remains constant, so let's go from 48 volts to 5 volts. It fluctuated a little bit. Or that could have been my my focusing, actually. Yeah, 499. That's fine. Wait, does the thing on the screen not update as often? Oh, okay. Okay, so I'd call that a success. Yeah, exactly, Johnny. So I think this is, as far as pink LEDs go, you know, that's just how it is. Good, so now we have 2 working boards, or in theory they're working. Let me try and plugging in this thing again and see if indeed the charger resets. Probably does. Yeah, I see it resetting. Yeah. Okay, yeah. If I plug in my phone, the USB-C part of this charger, it reboots to negotiate the voltages. So, yeah. Okay. So, well, that means that for right now, we're done, and these are built. And then tonight, at our normal streaming time, so 9:15, we'll do another stream, and we'll build the midpoint 1 and midpoint 2 boards. So that will be another few hours of streaming at least. There's less SMD components on there, I think. But more through hole, but you know, we'll see. And once that is done, maybe tonight we'll test something but it's probably going to be late already at that point. So then it's probably going to be streamed tomorrow where we test everything, including the new pass-through functionality. So you can now have, let's say, 5 midpoint 1 boards and then have a terminator on the last one. And in theory, then you can select the same channel on all 5 of them, and they should all do the same thing. But that's never been tested. So that's what we're going to test tonight. Or, well, tonight, tomorrow, sometime. Yeah, 2 hours, 20 minutes. I need to see in regards to my food when it gets here, and because we're ordering food. But it should be something like that. So let's. How many people are even here? I have no clue. Oh, there's 118 people here. Nice. It's almost sad to stop the stream. Damn it. Anyway, I have to, because I need to eat. Can I go to sleep? You can sleep for 2 hours and 2.5 hours, something like that. And then we'll start building again. So I hope to see most of you back in about 2.5 hours. And if not, thanks for joining. And if you're there, nicer hanging out, and I'll see you then. Where's the cancel button for this thing? Okay, I'll cancel the stream, stop the stream as normal. See you guys in about 2.5 hours. Bye-bye.